Welcome class to Chapter 5, Presenting GIS Data. This is where we're going to learn how to make maps and some rules on how to make really good maps in ArcGIS. So the art and science of making maps is called cartography. Cartography, you will learn a lot more when you take the base map and cartography GIS class as part of the certificate or the degree program. It's similar to graphical communication, and so we're going to learn some techniques on how to make really good maps and how to use maps for specific audiences and for specific objectives. You could think of a map as a model. It's an abstract representation of mostly the Earth's surface, or in general, reality. There are several books out there on how to make maps, how to make really good maps. So in this intro class, we aren't necessarily going to learn everything there is when it comes to cartography. That's what the base map and cartography course is for, and all these other books that specialize on making good maps. So what is a good map? We have to have your objective or goal. Who are the people that are going to read the map? That's a big one. When will it be used and where will it be used? Do we have all the data to compose or to make the map? What resources are available? And how sensitive is the map information? If we're plotting certain sensitive data such as Homeland Security data, we need to make sure that the map doesn't fall in the wrong hands. So there's a process, and you see the process right in front of you. Step one, think about what the distribution of this phenomenon might look like. What will the data that you use, how will it look in a map? Then in step two, you want to decide on what the audience is. What is the purpose or objective of the map? Those are the first two steps. The rest of the steps are iterative. In other words, they go back and forth and it's not necessarily linear. So you want to collect data for the purpose of the map in step 3, design the map using principles that we'll learn in this chapter, and then you might want to show the map to a few people that are included in the intended audience to see if the map makes sense. And if it doesn't, you may have to go back to step 3 and step 4 to continue to make the map better and better until you are satisfied and that the objective that you have will be interpreted by the intended audience. Down below, we're going to talk a little bit more about balance and alignment. One of the most common challenges of making a map is making sure the map window, or the actual area that shows the geography, along with all the map elements, are equally spaced throughout the page, the map page. For example, I would consider this map here on the left to be a bit more balanced than having all the map elements over here in the upper right hand corner. Here's a really good balanced map. So what this map has, and we're going to get into each of these map elements, we have maximized the area that we are mapping. And this is a map of South Carolina. Population by county based on the year 2000. So we're using, going back to chapter 4, we're using a graduated symbol showing different populations. Your legend is right here. You have a scale bar. It's not too big, but you can still read it. You have your sources, which is extremely important, and the author right here. You have a north arrow, which is also very important, and you have a neat line, which we'll talk a little bit more about this neat line that goes all the way around the area in a future lecture slide. In addition, sometimes this is important, we have coordinates. And these look like, well, if we look at the projection information, it's UTM zone 17 north. So these are XY coordinates within that UTM zone. Some of the big cities across South Carolina are labeled, and even the states that are surrounding South Carolina are on the map. So this is a pretty good map. It's balanced. If I were to add something else, I may add some kind of background image where it's white. But that's something that you will learn to do as we go along learning how to make maps. Scale bars. So a scale bar, as we probably have learned before when we were talking about projections or maybe in Geography 1, it basically shows you the distance in the real world compared to the distance on the map. So this first scale bar I actually like pretty well. Well, actually I like the first two because it's pretty simple, it's neat and concise. You have options of using other scale bars, but one of the most common challenges or mistakes is making the scale bar too big. And the other mistake is not using really nice whole numbers. For example, some students may end this scale bar with 176. It doesn't look as nice as using nice whole numbers like 200 or maybe even 1,000 or something that makes sense for the map. Also, north arrows. North arrows are very important, but you got to make sure that your north arrow isn't too large. I like this north arrow here in the upper left-hand corner. Very simple north arrows are really nice. A little bit more fancy north arrows are okay as long as they're not too big. But they're important to show the reader that north is up. Unless you're making a map where north is not up, then it's still very important. And then we have legends. So legends, unfortunately in ArcGIS, the default look of legends look really bad. So one thing you need to do is you need to go into your table of contents and make sure the names of features are not the original shapefile names probably, but a more descriptive and concise label. And in lab, we'll talk more about how to do this. But essentially a legend is there to make sure you understand what the colors and symbols on the map represent. And so one thing that might come up when you're creating legend is by default the word legend is included, and most cartographers and GIS users just eliminate that word legend. Again, this is something that we'll talk more about in Chapter 5 in the lab. And keep in mind that going forward, we will be continuing map making even after Chapter 5 because it takes quite a bit of practice to get really good at it. Sometimes, depending on the area that you are mapping, a north arrow may not be the best thing to use. For example, if we are plotting the United States along with Alaska, the north arrow doesn't really make sense because over here in Alaska, north should actually be somewhere right here. So instead of using a north arrow, you can use graticules. And they show your longitude lines along with latitude lines and helps you figure out where north is, which is basically anywhere along the longitude line. There are also some other rules. Visual hierarchy. Most important information is usually in the upper left-hand part, at least in the lower right-hand. Keep that in mind as you are creating your maps. Also, the center point of a map isn't necessarily the focus. It's just slightly above the center of the map. So you want to make sure the center of your map data is a little bit higher than the center of the map page. Again, we'll talk a little bit more about this in lab. Map balance. Map balance is one of the most tricky things to do. Now, in my experience, the first thing I want to do is I want to make sure that the area that I'm mapping is as big as possible, but you still have room to add all of your map elements like legend, north arrow, scale bar, author, citation, projection, etc. So out of these 6 maps of Africa, I would say this one is the one that is centered pretty evenly, and that still gives me some room to add all those other map elements. And you also want to include a neat line around all of your map elements. That makes the map look a lot nicer. But remember, don't make your other map elements too big. So you might, in fact, when you're starting to add all the map elements around this Africa, the one that I circled or highlighted, you might realize, there's still a lot of space. Let's make the map size, let's make Africa a little bigger. And then if you end up putting really large map elements, then you need to make them smaller and then make the map element bigger yet. Here are some examples. South America in the upper left-hand corner, this version is a pretty good version, although you might notice that the map of South America is a little too small. Your legend might be a little too large. Over here on the right, the point is that if you're using these maps in publication, you can probably put a lot of the title and citation information in the figure caption. Down below here, which representation of South America do you think looks the best? Is it the left, center, or right? So the center one, yes, South America looks pretty balanced, but the title is covering part of South America, and so is the legend. On the right, it's the same thing. The title is it's too big and it's covering part of South America. So the one on the left, even though I still think it's not ideal, is your best choice. You're showing the entire South American continent, and you have enough room to put your map elements. Here's another one. Now, sometimes you have to decide, as far as the map page or the map layout, am I going to use a portrait? This here is a portrait version where it's taller than it is wide, or a landscape version where it's wider than it is tall. So there are several problems with the map on the left. First of all, the data that you're mapping is very small. We need something that maximizes that. The title is just sort of randomly right above it, and you have way too much white space here. If you're mapping the United States, you do not want to include Alaska in the upper left-hand corner, because it doesn't look good and it doesn't go with the north arrow. The legend has the word legend in it, which so does the one on the right, but generally speaking, you don't want that in there. And it's just a poor design altogether. I can't really read the scale bar, but I bet the scale bar values are not rounded either. A better design is the one on the right, where it puts the entire United States in a much better place. You have the legend and the author and the citation, the north arrow, the scale bar, they're not too large. You have the density, or I should say the title above it. It's still not ideal. I would make this a little bit bigger, but it's a better design. Going back to Chapter 4 a little bit, we also still have to think about symbols and colors. So if we take a look at these 3 different maps, which one looks better? Which one is easier to understand and which one shows the roads better? First of all, the colors represent higher or lower population. This first one here, I'm going to underline it. The blue is showing higher population and the red is showing lower population. Most people, this is sort of like symbol psychology, most people associate red with either danger or more, like have a higher value. So you don't want to use blue for your most populous counties. This one here has a better color scheme. But one issue is that the boundaries of the counties may look they're a little too dark because it also starts to look like roads. So I would probably choose the one on the bottom right, where you have a lighter boundary for the counties. You have red for the populations that are higher than the other counties, and you have the roads that show up a little bit better. Another way, let's say we're mapping the entire world, you might want to use natural or pastel colors. The top figure, first of all, the latitude and longitude, or the grid lines, are way too dark. It covers too much of the continents. The water is too dark. Your eyes are drawn to the water more than the land. So on the bottom here, the continents look a little bit better. They have a little bit more of a natural color that would represent land, and the water looks a little bit more natural as well. And those grid lines aren't so obvious. They're there, they're very subtle, so that makes a better map. And again, we talked more about this in Chapter 4, but we want to make sure we don't use too many colors when we're dealing with graduated colors or choropleth maps. We make sure you want to use the right kind of symbols. If you're using a symbol like that, that might represent hospital. These might represent schools, but you need to put that in the legend. The water in the lower left-hand side looks like it covers the United States and Mexico. So you don't want to use let's say green, beige, yellow, brown colors for the water. You want to try to use a blue color for water. And when you're dealing with hazards, you want to use the highest danger or hazard with a red color, and maybe lower danger using a green or a light red versus a dark red. Okay, remember when I said that the default for legends is really bad in ArcGIS? So what you're seeing here on the left is the default. So you might have a shapefile called cities.shape. And when you create a legend, the first thing is they put the word legend. They use whatever the file name is. They may use the attribute heading, and then they just use these numbers that you might want to put commas in here because they're kind of hard to read. The formatting isn't good. So the one on the right is much better. Even though they still use legend, now you have written out US cities instead of cities.shape. It's much more clear. 1990 population, it's written out much more clearly, and you have commas where they go, making these numbers much easier to read. This map has a lot of problems. First of all, let's see if you can figure this out. First of all, the title is way too big. They use states.shape, so they didn't rename that heading. They use way too many colors. I don't even know what they're trying to plot. Oh, they're trying to plot gender ratio, but are these numbers percent? Are they decimal? Is that what they're supposed to be? And you're plotting lower values to higher values. So going back to Chapter 4, we probably want to use just one color and use different shades of that color. Because when you look at the actual map, you don't see patterns. You just see random colors. This area that I just highlighted is too small. It for a map, the map area should be the largest piece. The north arrow is way too big. Even though this person used nice rounded values for a scale bar, some of it's going off the map, outside of the neat line. So there are several problems here. Now this is a much better map. The mapped area, the United States, including Alaska and Hawaii, and another little inset map, which we'll talk later on, are appropriately sized. We have a nice title, we have your clear legend, and other information around so that the map looks really balanced. There's not a lot of empty space. The problem with this map, though, Democratic counties are usually in shades of blue, and Republican counties are usually in shades of red. Otherwise, this map is a really good map. This is an example of using different shades of one color, or at least colors that are very similar to each other. So this is showing you the number of census divisions. So it says, or actually if you read the description, is percentage of population age 14 years and under. And if you look at the percentages here, the higher percentages are darker and the lower percentages are lighter in color, which makes sense to a person trying to understand this a little bit better. Okay, what is wrong with this map? First, as we mentioned earlier, you can't use a north arrow because north is not up. No, that doesn't work here for Alaska. North is really like this. So you should use graticules. There are these colors are way too different from each other, so you do not see the patterns. The area is way too small. The scale bar doesn't have a nice round number. You have Hawaii labeled way too many times, and the labels for the states are just, you can't see the states because of the labels. This is a terrible map. And so I'm hoping, and I'm going to be putting some examples on Canvas, that you can see why certain maps are bad and what makes a good map. Another problem here is there's a lot of empty space, and the map area is not big enough. There's probably even more problems, but that's, oh yeah, look at these numbers. You don't need to put 31.300000. You can get rid of those zeros as well. One aspect of coordinate systems that is relevant to a map, bottom line, you should not ever use a geographic coordinate system when you are mapping. So take a look at the map on the left. What it does is it really distorts certain states. And this line here is really not a straight line. This, using a a country-wide or continent-wide projection, is a much better way of displaying your data. So again, anything that's unprojected would be considered a geographic coordinate system. It's based on latitude and longitude values. And remember, the space between longitude values, it changes as we go. It actually gets smaller as we get closer to the poles. So this introduces a lot of distortion. That's why projected maps, especially small scale maps, are much better to use. So this is an example. We've talked about this in a previous lecture in Chapter 3. Again, projected coordinates and coordinate systems, you want to use that for your map. This is a review. Now, let's say your objective of a map is for navigation. Navigation maps are best used when the area is distorted, but the shape and direction are not distorted. But if you're using a map to assess your shape, or I should say not shape, but direction and distance, you might want to use one that preserves distance, like an equidistant map. So it really depends on what your objective is. If your objective is just to display data, then you have more opportunities or more options for using different kinds of projections. But if you have a very specific objective that includes area, shape, distance, or direction, then you want to use the most suitable projection for the property you want to preserve. This is just a review of different types of projections. These are actually classes of projections. Your cylindrical, which are best around the tropical regions, conic, best around the mid-latitudes, and azimuthal. And if that azimuthal plane is located on a pole, then those maps are best representing the polar regions. So I just passed through that slide. Of course, we need to use a projected coordinate system to make accurate measurements, to preserve one of those 4 properties. This is really useful in a small scale map, and your organization, the company you work for, may actually demand. This brings me back to when I first started my my work at a geologic consulting firm back in 2007. I used, for the state of California, an unprojected coordinate system. And what that did is it made Northern California much bigger than it really is. So the first thing my boss said was, please use a California-based projection, whether that is UTM Zone 10 or 11 or a California State Plane Zone. That's when I decided, wow, it really does make a difference, especially with small scale maps, but even with large scale maps, you might have to decide which projection you're going to use. So these are some questions to try to figure out what projection to use. Again, what spatial property do I want to preserve? Where am I mapping? What is the shape? Remember back in Chapter 3, if you're mapping something that has a much more north-south orientation, it might be suitable to use a UTM coordinate system. But if your area has a more east-west orientation, then you may have to use a state plane coordinate system. So these are the UTM zones once again on the left-hand side, and the state plane zones on the right-hand side. So this just gives you some ideas for the kinds of projections you may want to use for small-scale maps. Again, if you want to preserve distance and area, you want to make sure you select an equal area map. But shape, let's say you want to keep shape, or you just have general purpose maps, then you might be able to use additional equidistant, equal area, it really doesn't matter, or even Lambert conformal conic to show your data. It really has to do with what your purpose is for your map and what distortion you want to live with. Okay, so let's go back and talk a little bit about units. Map units, and this is when we go into the map layout, which we'll talk about in lab. Map units are determined by the actual coordinate system. So you cannot change the map units. The map units are usually in feet, meters, or decimal degrees. Again, decimal degrees is for a geographic coordinate system, and if you're mapping, you should not be using a geographic coordinate system. So most of your units will be in feet or meters. Now you can change the display units on that map. For example, let's say my coordinate system was UTM NAD 83 Zone 11 North, which is good for a Southern California map. But on Southern California, I want to know where my latitude and longitude values are. I can go to display units, and I could display latitude and longitude on there, even though the map units would be in meters. And page units are the actual inches of the page document. Again, usually in inches, and if you prefer, you can probably change that to centimeters. So as a review, You have your data in a coordinate system. This gives you, you have UTM, which is typically in meters, geographic coordinate system, typically decimal degrees, or degrees, minutes, and seconds. You can change that. Or sometimes state plane will use feet. So map units are fixed by the coordinate system. Display units you can change, and we'll show you how to do that in the lab. So, well, this is a little sneak peek that I'll show you. If you go to Data Frame Properties in your table of contents, in the General tab, you have your map units. Notice that it's grayed out because you can't change that. You can change the display units really easily. And in this case, we're changing it to degrees, minutes, and seconds. So this is just a start. I like to think of Chapter 5 as a start on how to make good maps. We will do a lot more map making exercises in Chapter 5, but we're going to continue to make maps going forward. And then even in additional or more advanced GIS courses, you're going to continue to practice and really get skilled at making a good map. Thank you, and see you next time.